Okay, so this is our last video for today's lecture. Now we know how to use backward induction to solve dynamic games. Let's apply it to a pricing problem in a supply chain. Consider a supply chain with a manufacturer and a retailer. The manufacturer makes the product and sells it to the retailer, and then the retailer sells to the market. The unit production cost of making a product is C. The wholesale price chosen by the manufacturer is W, and the retailer sells to the market at a retail price R. Given that the demand will be A minus BR, where A and B are just constants. Okay? In this game, the manufacturer chooses the wholesale price, and then the retailer chooses the retail price. So this is a dynamic game because the manufacturer is the leader, and then the reader is the follower. Okay, so now after this, each of them will maximize their profit. Okay, that's how they make their decisions. They will choose their prices individually to maximize its own profit. So let's try to formulate and solve this game. Let's focus on the retailer side first. To make the derivation easier, let's assume A and B are 1 and C is 0 for a while. So D becomes this and there is no cost at all. Suppose we are looking at the retailer. Given the wholesale price, okay, the wholesale price has been announced and fixed. Given the wholesale price, the retailer's problem is this one. R minus W is the margin, and 1 minus R is the resulting quantity. With this, immediately we can solve for the optimal solution here. W plus 1 over 2 is the retailer's best response to any wholesale price. Okay, this is definitely a function of the wholesale price, and we can see some intuitive results. When the wholesale price becomes larger, what's going to happen to the retail price? The retail price will also become larger. Okay, if the wholesale price becomes 1 unit larger, the retail price is going to become 1/2 unit larger. So this creates two meanings. First, if your supplier charges you more, then you have the pressure and you must also make your price higher so that you can get the maximized profit. Okay, so that's something. Also, quantitatively, we observe that for every single dollar increase in the wholesale price, the retailer only increase 1/2 dollar in the retail price. That means when the manufacturer increases the margin, the retailer will decrease its margin. Okay, he does not want to do that, but he has no choices because that's the only way to compensate the manufacturer's margin increase, because the increased margin is going to decrease the demand. The retailer must make sure that the demand is still okay, so the retailer must decrease its margin. Anyway, intuitively, this solution looks fine, so let's continue. Now we have this prediction in mind. The retailer knows once W is chosen, the retail price will be this one. So now, the manufacturer can also calculate the order quantity or the sales quantity to the retailer, because 1 minus R is going to be 1 minus W over 2. Okay? Naturally, when the manufacturer increases the wholesale price, the total demand will become smaller. This is not because the customers can see W directly, right? The consumers just don't care about the wholesale price. It's that this is an indirect effect. When I increase my wholesale price, the retailer is going to also increase his retail price. That's why the demand becomes smaller. Anyway, now we have the wholesale price minus 0 as the margin, and then this is the sales quantity. The manufacturer solves this problem and get 1/2 as his optimal solution. Okay, something that we can do. Here, I want to say more about it. The first thing that we want to compare is about the two prices. The wholesale price is 1/2 and the retail price is 3/4. This is a common practice called markup. The retailer is going to add a positive margin to the wholesale price, naturally, because the retailer wants to make money. Okay, so the price can only goes up when you have more layers in your supply chain. And then the sales volume, the retailer's manufacturer's profit can all be calculated according to the formula or the model we use. In total, we can see the retailer can earn 1/16, the manufacturer earns 1/8, and together they earn 3/16. Okay, this can be done. When we assume the parameters are 1, 1, and 0, we get something like this. Okay, easy. But if we try to use the original model with A, B, and C, probably we can still solve it, right? And then we will have these equilibrium profits, equilibrium prices as functions of our parameters. And then we can do comparative statistics to show how those parameters change will affect our equilibrium outcome. Let's try this. So in general, the retailer's problem is to solve this. The demand function in general is A minus BR. Okay? Through some arithmetics, we can show that the optimal solution is BW plus A over 2B. Okay. Just a reminder, if you forgot how to solve it, first order condition. Okay? Now we have this. Probably you want to do some intuitive test, okay? What's going to happen when A goes up? What's going to happen when B goes up? You actually have done so in first week's lecture. And then the manufacturer predicts the result. So given the wholesale price, this will be the retail price. So given the wholesale price, I know what will be the retail price. Okay? Nothing special. The manufacturer problem is so formulated like this, and then the optimal wholesale price is this one. Let's do some investigations. When A goes up, wholesale price goes up, good. When C goes up, the wholesale price goes up, good, because the cost becomes higher. When B goes up, you may want to do a verification. You can see that the price is going to go down, right? Because if consumers are more sensitive to your price to the retail price, what you may do is to decrease your price a little bit. Anyway, that's something we will always try to do when we have an analytical solution. Let's continue. In equilibrium, the wholesale price will be this one. So the retail price will be this one, as we can calculate. The qualitative impact of A, B, and C on the retail price is actually the same for that about the wholesale price, right? Because the formula looks very similar. The sales volume will become A minus BC over 4. Okay? Here, when A goes up, the sales volume will go up because the consumers like this product more. But if the cost goes up or the price sensitivity goes up, then less consumer will buy this product. Eventually, the retailers earn something, the manufacturer earns something, and all together we can get this. It's just that A minus BC is a constant there. A minus BC squared over B is a constant there. But this 3/16 should not be weird to you, because you have observed that when we have the illustrative case. The last thing is to compare the equilibrium outcome with a cooperative supply chain or integrated supply chain. Suppose the two companies can integrate or can collaborate to set the price. Okay, let's see what should they do. There is at least one way or one proposal that can make them better. Let's say the wholesale price is C and the retail price is 1/2. Suppose they do this. Suppose they choose a wholesale price as C and the retail price as 1/2. Well, here we are assuming that the parameters are 1, 1, and 0. In this case, the sales volume will be 1/2 and the total profit will be 1/4. If you remind yourself about the pricing problem we discussed in our first lecture, this is actually what a single firm will do. Okay? This is actually what a monopolist will do. So, the monopolist or the integrated two firms should actually do this. So we call this first best. Okay, this is the best thing they may do. If there is a first best, then of course there will be second best. Okay, we will talk about that in the future. But here, keep in mind, this is actually what a single firm or the two firms cooperated two firms will do. And more importantly, this number is greater than 3/16, right? So again, decentralization creates some kind of inefficiency in this channel or in this supply chain. When the two firms do not cooperate, they earn less. Okay, they earn less. They are making inefficient decisions. That's the result. Now, let's discuss how may we split the pie to get a win-win situation. If we have 1/4 all together, but previously the manufacturer can earn 1/8 and the manufacturer can earn 1/16, then the very easy thing to split this 1/4 is that I first give 1/8 to the manufacturer, and then I give 1/16 to the retailer, and then I still have 1/16 remain. I can split that maybe equally to both of them, or to use whatever method to give both of them. So it's very easy to find a way to coordinate these two companies and then split the pie to result in the win-win situation. Okay? At the end, I would like to invite you to think about a question. Previously, when we talk about the corner competition, we say it's inefficient, but consumers like it. Okay, consumers prefers the firms to be decentralized. Please think about whether consumers prefers a decentralized system in this pricing and supply chain problem. Okay, it depends on whether consumers can buy cheaper products. That's something the consumers care about. Okay, teach yourself or think about it by yourself. If you are a consumer, do you prefer the supply chain to be coordinated or decentralized? Think about it. Let's discuss it in class. Okay, that's the end of today's lecture. Thank you.